Record.
That's what. That's it.
Okay.
Okay.
We're looking over there.
Yeah.
Okay, we're now looking at what is essentially a three-plane loop antenna. It picks up a magnetic field is essentially what it picks up in the textbook functions. It's an XYZ loop. That means one runs north-south, the other runs east-west, and the third runs horizontal. This one is the north-south loop. This one is the east-west loop. And this one is the horizontal loop.
Okay.
Now, if we pan over this way,
It's quite impressive.
this antenna, don't leave it for a minute.
Okay.
This antenna covers roughly a frequency range of about 10 hertz up to about 30 megahertz is the frequency range of this. And with this, we can do radio direction finding. Because we can get by using a device known as a goniometer, we can get a direction out of the east, west, north, south loop using quadrature functions. Now, if we pan over to the north, you'll see the disc cone antenna.
Okay.
That is an antenna that is based on a conical function, which is a self-scaling log periodic type antenna. That covers 25 megahertz to 1300 according to the claim of Radio Shack. Actuality, it'll probably cover about 50 megs to about 1.5 gigahertz.
Okay.
Now, if we pan over all the way to the left, I don't know how the camera will pick it up, but you'll see the long wire, which is a typical Hertzian doublet dipole antenna. The long wire.
See, can we get that?
If nothing else, you'll get the insulators going up to it.
Right.
You'll see there's two wires coming off that top insulator, going off 45 feet in either direction.
Yes.
That's a dipole. That is also called a doublet,
Okay.
or a Hertzian dipole antenna.
Right.
That's an electrostatic antenna. That's an E-field antenna. And that covers, theoretically, down to 10 hertz also, but you have to have very high impedances for 10 hertz, which I have, and that goes up to about 30 megs, that antenna.
Well, so basically this can be a low wave, a long wave.
Oh, yeah.
Extremely low frequency.
Depending upon how you match it out, how you match it up to the receiver. This will transmit down to about 3 megahertz. From 3 to 30 you can match this up to, using a device known as a matchbox. The disc cone will transmit 60 megs to 1200 megs.
Yeah.
And then the dual decahedron, the dual octahedron antenna will transmit up to about 20 megs.
Okay.
And also, this antenna, if you want to pan back to that.
Certainly. This one?
Yeah.
Okay. See?
I loosen the pan.
Yeah.
Turn that handle. Turn it.
Okay.
Should turn.
Let's focus it back.
Okay.
Okay. That's good. Good.
If you fill in the size of that antenna from coil to coil, what you'll end up with is actually two pyramids with the bases together and the points one up and point one down.
Right.
So this can also, for the metaphysicists, this is also a pyramidal type structure, this antenna.
Yes.
This is the reason Jerry and George here feel like a wind coming off that antenna, because that antenna is pulling out of the sky, pulling out of the ground, and resonating out.
Okay. Yes, a very powerful pressure sensation.
Yeah. That antenna is an accumulator in itself.
Okay. George, where do you seem to feel the pressure? Feel pressure at any particular point?
No.
Okay. Well, I was feeling it off of the corners. Right off the corners of the cell itself. Very powerful sensation.
This is the antenna setup of Space-Time Laboratories. We use this for monitoring.
Okay.
With this setup, we can monitor 10 hertz to about 1.2 gigahertz, although I have receivers that go up to 2 gigahertz. Okay, I guess we shut this off and go downstairs.
How about this one?
They're not active.
Okay.
What's upstairs?
Could I ask you a question about the other antennas? How do they figure in any kind of, let's say, radionic or psychotronic functions? I mean, are you able to pull signal?
This one will transmit almost a pure scalar.
And now you're talking about the
long wire.
The long wire. Okay. All right. Let's see if we can focus. It's hard to see the long wire for the trees, but
it didn't come in well on the camera either.
That's okay.
35 millimeter camera.
Right, it's there. It's just above the treetop level. You can see it.
You should see the white insulators right in the center.
Okay, pick it up. Okay.
Coming close to this antenna, I can pick it up at least 50 feet away.
Right. Yeah, this is the thing I felt coming up the ladder. Especially for some reason, I feel it especially from this point.
Speak up, Jerry.
Okay. I feel the pressure very powerfully from this point in particular. Is there a reason for that one? I mean, the others seem to be kind of...
Well, you got to remember, you're at the co-juncture of the third point. Here, what's this? You're at the co-juncture of the point.
Right. So this point, I don't know, personally it seems to be the most powerful to me anyway.
Each person will feel a little bit differently.
Okay, that's interesting.
You know, human senses do vary from human being to human being.
Certainly do.
This is the problem with parapsychology. You know, what do you call a standard?
Yeah, this is true. I've often thought that the differences that people confess or receive should be additive. In other words,
if you want to move over there, we can get a different view of it.
Yeah.
You got pause?
Sure.
How's it look?
Okay, very good.
Oh yeah, you got it.
Yeah. Okay.
Here we see the parallel transmission line leading up to the dipole. We use this instead of coax cables because this type of line is better for carrying etheric or relativistic functions. This is not as lossy.
Yes. It does seem pretty significant to me that the early researchers who investigated this kind of phenomenon developed these kind of devices first.
This is the etheric transmission line. I don't know if you can focus in on that.
Okay. Yeah, we can see that.
Okay, this is a specially designed transmission line for etheric signals. You'll notice this is like a specialized plastic for the semiconductor. And this is a solid aluminum sheet. It's not braided. You see it's got a very heavy cable that quite closely resembles the cable leading up. This is what you have to use in UHF and VHF structures, because open transmission lines don't work all that well. And you'll see that line at the base of this antenna over there.
Okay, let's swing around. And we're looking
at the base of that tower.
At
you'll
the base
see
of the tower.
Transmission line I just showed you.
Absolutely. It's wrapped around the bottom there.
Mm-hmm. Okay. And that goes up, if you want to pan up, you can see that goes up to this cone for the UHF and VHF signal.
Right.
Excuse me for
Okay. Straight up this way, and we'll pull back. Lovely view. Lovely view.
And then if we pan over towards you can get another view of the pyramid of the plant.
Surely.
You see the work in process.
Surely.
You see the work in process table.
Okay.
And you see all the wires coming to the base of it. All right, let's go over here. this place?
Yes, we will. That's quite a wrap.
Gotta get it out.
How long did it take you to splice that? About 20 minutes?
You guys kidding? 3 hours.
It looks organic.
This is one of our termination pods. You see all the wires.
Okay.
Can you zoom in on that?
Yes. Yes, we are.
This is the terminations for all the loops in here. This is for the horizontal loop. We have 3 of these. You know, if you can come in and zoom in on the table,
Yeah.
you can get a good shot of the table. You can see the different pods. You know, all the wiring.
Okay. That's lovely work. It's lovely and complicated work.
And that still is in process, that one.
Yeah. I wanted to bring out and emphasize the idea that the early researchers, working by intuition mostly, seemed to develop these etherically active devices rather fluidly. And then when the engineers seemed to get a hold of it, they selected out certain functions in the signals and eradicated the others. What do you feel about that?
I agree with you. Well, we can go more into that when we get out of the sun and get downstairs in the shop.
Okay. All right. Let's just take a last look at this beautiful antenna.
A lovely recording of the neighbor's dog.
Okay.
That should add to the atmosphere of this. Dogs barking
Well,
in the background, kids.
it's real. Can you show us the Rogers antenna downstairs?
Yeah, that'll be downstairs.
Love to see that. Okay, we'll pick up in a second. Okay.
Okay, what we're looking at here, I know it looks like 2 black wires coming out of the ground.
Can we outline them? Yes.
Here and here. And then we got a wire leading off there. What this is, at the turn of the century, Larry Rogers, I think it was Larry Rogers, designed what was called the Rogers radio system. This was essentially his concept, was to take a coaxial antenna structure and bury it. And one day, about 8 months ago, we had a ditch witch here, and we dug a ditch that went this way and went that way. It goes to either end of the property, and this is the center point.
Okay.
This wire goes into the ground and goes that way. This wire goes into the ground and goes that way. And it's a doublet on the ground. That's all it is. This goes into the receiver room, and we can listen to the signals that are in the earth itself. The Navy used this type of thing as an emergency communications to the submarines for years and years and years, because this could reliably transmit a signal or receive from the submarines.
Okay.
Because the ocean is part of the earth.
Right.
You know, there is much less reflection angles from the earth, you know, from dirt to the ocean than from ocean to air for airborne signals like the other antennas we looked at.
Now that goes down about 3 feet, right?
It's about 3 feet down.
Okay. Now, simply by submerging the cable,
We put it inside the earth, and we're using the earth here as a media of transmission and reception.
right.
This will tell me what signals are in the earth.
Okay. Yes, this is impressive. Also, how insulated must these wires be?
Very.
Highly insulated.
I used that etheric transmission line and buried it and connected up the center cable and let the outer cable float. So you look at the original Rogers patent, he had a steel pipe, and then down the center of the steel pipe he put the actual antenna inside the center of the steel pipe.
Okay.
Which is a coaxial structure. So a coaxial cable does the same thing very nicely.
Right. Okay. We're focusing on you a little.
But essentially he took a steel piece of pipe and just suspended a wire in the center of it on insulators.
I see.
And then buried this whole thing in the earth. That's all we can say on the Rogers. You got a wrap here.
Okay. Okay.
Now we go inside.
Residents of this antenna.
Yes, sir.
I felt